All right, guys, welcome back. We're getting into our next section of notes for this unit where we're going through parallel and perpendicular lines. Lesson for today is going to be 3.2, different types of angles. And today, basically, what we're getting into is we still have the same diagram that we've talked about where we have two parallel lines and they're being intersected by a transversal. And we noticed all these different angles that we have. Now we're going to add in more types of angle pairs. So last time we just talked about corresponding angles. Now we have more to add to that and more information that we know with those. Okay. So date today is the 28th. If you'd like to add that, and then objective, kind of like I said, we're still using kind of algebra and different variables to solve for x, and then solve for different measurements as well. Okay. So first thing I'll have you do here, a little review. I mentioned this earlier, but we're going to see this kind of diagram a lot. So I'll give you a second. I want you to pause your video, and I want you to sketch this diagram for me. Okay, so hopefully you have this sketched here. If I'm looking at this, it says I want to identify all the sets of congruent angles in this picture here. So let's start. Let's just start with angle 1. So we have angle 1 here, and we can use a few different things to come up with other angles that we know are also congruent to angle 1. So I'm going to say angle 1 out here is congruent to. Okay, well, before even this unit, if I just, cover up, I guess I can't do that with my hand, but if I just cover up the bottom part, if I'm just looking at the top 4 angles, we know that it's congruent to angle 4. Because we've talked about this, these are vertical angles, they're opposite of each other. So I know angle 1 is congruent to angle 4. Okay, and then using what we talked about last lesson as well, I know 1 is also congruent to the corresponding angle, or the angle that's in the same spot on the other line. So in this case, the angle that corresponds to angle 1 would be angle 5 here, because notice they're in the same spot. They're both in the top left of their respective angle groups. So I have angle 5 here. And then lastly, what else? We know one more, using either vertical angles or corresponding angles. We know 8 is congruent to all of these as well. All 4 of these have the same measure. And again, the reason for that is either 5 and 8 are vertical angles, or 4 and 8 are both in the same spot. They're corresponding. Okay, so that's one group of angles that we know are congruent. And then if we go along with that same idea, if I just start with angle 2 here, I'll just put a box around these. Angle 2 is congruent to a few different things. We know vertical angles, so we know it's congruent to angle 3. And I'll just go through the rest of these, right? We know angle 2 and angle 6 are corresponding. They're both in the top right, or in the same spot with their selective groups. So I can say those are all congruent to angle 6. And then lastly, same thing with angle 7, right? We know all 4 of these are congruent as well. Okay, we're not saying these are congruent to these here, but we're saying each of these groups of 4 we know are all going to be congruent to each other. Okay, so we can use that, and we did problems like this last time where I just gave you one angle, and if I just give you one, you know the other 7, because we know at least 3 others are congruent, and then we know the remaining 4 are going to be supplementary. And so we have names for different types of angle pairs that we can be looking for, so that instead of having to write out 8 different angles every time I draw this diagram, let's say I just give you 2. Could you name them? Do we have a specific name for them? And then could I set up a problem to solve for those measures here? Okay, so that's why we have these names today. All right, so first definition, one of these names that we're going to talk about is called the alternate interior, I was going to go with the theorem, but let's just say the definition for interior angles. Alternate interior angles is the first one here. So what this says, and it's going to go right along with the name itself. The definition of this is a pair of angles that are on opposite sides or alternate sides of the transversal. And just for the sake of shortening these definitions, we're just going to assume we're using a diagram that we've been talking about already. 2 parallel lines cut by a transversal. A pair of angles that are, I'm missing words here, I'm sorry guys, that are on opposite sides of the transversal and on the inside of the parallel lines. Okay, a pair of angles that are on opposite sides of the transversal and are on the inside of the parallel lines. So we have names for these, And in the names, it tells me what kind of angle pairs I'm dealing with here. And we're always going to be talking about the location of it in respect to the transversal. So are they on the same side or opposite side of the transversal? And then are they on the inside or the outside of the parallel lines? Okay, those would be the two things we're looking for. So for example, if I'm looking at these here, and actually we're going to do one thing before we look at these here. One reason this is helpful, why is this important about alternate interior angles? One thing I know about this is they are, see if it lets me write, they are always congruent. I want you to add this to your definition as well. I'll underline that here as well. Alternate interior angles are always congruent. So now that we have that information, now that's going to help us set up problems. Let's talk about a few examples from that diagram that we've already had written down. So if we're using this one here, I'll erase all these to make it a little bit simpler to see. We're looking for two angles that are, number one, on the opposite sides of the transversal. So looking at this transversal here, a pair of angles, and then on the interior, so on the inside of the parallel lines here. So on the inside. So with that being the case, we have four angles to choose from. So if we look at, for instance, here, angle 4, the alternate interior angle of angle 4 would be angle 5. It's on the opposite side of the transversal, and it's on the inside. Both of them are on the inside of the parallel lines. Okay, so I'll just write this here as an example. Angle 4 and angle 5 would be alternate interior angles. And like we said, they're going to be congruent, right? Going along with that information. And then same thing here as well. Another example of these would be angle 3 and angle 6. We'll say this here. Angle 3 is congruent to angle 6. Okay, and again, reason for that, they're both on the inside of the parallel lines. They're both on opposite sides of the transversal. Okay, next one here, alternate exterior angles. You guys can guess what this is going to be as well. If you need to copy different words from the last one, you can do that. This is a pair of angles that are, I'll try to block this out here, that are on opposite sides of the transversal and in this case, instead of being on the interior or the inside, we say the exterior, so the outside, and on the outside of the parallel lines. So again, same kind of thing. They're both on alternate sides, except now we're just talking about exterior. Now we're talking about the outside angles. Information that we need to add with this when we're done writing the definition, same thing as alternate interior. They are always congruent. If I see alternate exterior angles, it's the same kind of idea. They're always going to be congruent as well. Okay, so if I scroll back up here, if we look at this, notice same kind of thing. We're looking for angles that are on opposite sides of this transversal, but now we're talking about the exterior. So if we have this choice of these angles that are on the outside here, for instance, if I look at angle 1, that would be the alternate exterior angle to angle 1 would be angle 8. It's on opposite sides of the transversal. And then another example here would be angle 2 and angle 7. So I'll scroll down and write those. Examples here, we can say angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Okay, and we know that holds, or we know that information is true because we've already written that earlier. 1 and 8 are congruent, 4 and 5 are alternate interior, 2 and 7, and then 3 and 6. So anytime I see that alternate interior, alternate exterior, just think congruent. Okay, so example 1 here, these are different numbers, so I'm going to have you, you know what, you don't need to write this one. Actually, I lied. You do need to write this one. So I'm going to have you pause your video, and I want you to sketch this diagram for me. Okay, so hopefully we have all that written in. Shouldn't take too long to draw that diagram. And we have different numbers here, so that's why I wanted you to write it this time. In this case, we're told measure of angle 1 is 7x minus 15, and measure of angle 5 is x plus 57. I want to know two things. Number one, what is the name of the angles, or what type of angles am I looking at with these two? And then what is x? So first thing here, if we're given information about these, if I want to, I can just include this on my diagram. So angle 1 is 7x minus 15. And then angle 5 is x plus 57. So I'll just go ahead and include that there. Okay, so just labeling. All right, and now I want to work through this here. So I see angle 1 and angle 5, and I need to ask myself that question, what kind of angles am I looking at here? Well, to do that, all I need to ask myself is, are they on the same side or opposite side of the transversal, and they are then inside or the outside of the parallel lines. So right here, I see they're both on the outside of the parallel lines, and then on opposite sides of the transversal. So these are going to be alternate exterior angles. Alternate exterior angles. And I'm going to move myself here. All right, so that's the first piece, alternate exterior angles. And then second thing is, how do I solve for x? Good news is that we don't have to set up a proof. We just need to set up our equation and solve like we normally would at the beginning of the year. So we have these two angles here. We've said that they're congruent, which we know as geometry students means that they're equal. So I'm just going to set them equal to each other. 7x minus 15 equals x plus 57. Okay? And then we solve like normal. So multiple ways to do this. I'm just going to deal with the variable first. So subtract x from both sides. When I do that, I'm left with 6x minus 15 equals 57. Continue to work through this here. We have a negative 15. I want to get rid of that, so I add 15 to both sides. I'm left with 6x on the left side. On the right side, get in the habit of trying to do these in your head. It's just good practice for you guys as honor students to try to, reinforce that without, reinforce your mental math skills. So 57 plus 15 is 72. And then final step here, we know is to divide by 6. And again, you can try to do this in your head. If not, just use a calculator, but x equals 72 divided by 6, that would be 12. Whoop. Backspace here. X equals 12 here. Okay, and then I'll circle that, and that is going to be my final answer. We know just continuing that strategy, making sure that once we find x, double checking and seeing, do I need to plug this back in? In this case, it was just asking for x, so we are good. Okay, so again, just fairly simple, just kind of like we did with corresponding angles. I'm just setting them equal to each other and then solving, as long as I know how to identify them there. All right, next set of definitions that we need to know here. Same side interior angles and same side exterior angles. Okay, in this case, I'm going to write the whole definition. You guys can choose how much you want to write, depending on how much you feel like you'll need to remember this here. All right, but the definition for same side interior angles, you guys can kind of guess, is a pair of angles. A pair of angles that are on, instead of the opposite sides, we're now going to say, just like the name says, on the same side of the transversal. So first piece, same side of the transversal, and since it's interior angles, we're going to say on the inside of the parallel lines. Inside of the parallel lines. Okay, and we'll take some examples from last time as well here, but again, just using that idea. Same side interior angles this time. Same side of the transversal, and then inside or interior. So if I'm looking at this here, one example of same side interior angles, we're looking at this here, remember interior. So for instance, if I start with angle 4 again, this time on the same side of the transversal, the only other angle would be angle 6. So angle 4 and 6 would be an example of this. Going along those same kind of lines, if I look at angle 3, so we'll just connect those there. Okay, angle 3, the same side interior angle would be angle 5. And notice we can't say that they're congruent necessarily. We might know that, we might not. But the one piece of information that we do know with these is that they're always going to be supplementary. They are, so I'm going to add this to the definition here. They are always supplementary. I'll underline that here. Always supplementary. So in this case, not congruent. We're changing it up now, but they are always going to be supplementary. And I can explain that. We can look at that and see we have a linear pair there with some of the different angles. And so the corresponding ones would give you the same thing. They're all supplementary. All right. Same thing with same side exterior angles. Same side exterior angles are a pair of angles that are on the, again, since we said same side, they're on the same side of the transversal. And then just to cap this off, remember since it's exterior, we're talking about the outside. So and on the outside of the parallel lines. And I'm going to use the little parallel symbol again to describe that, parallel lines. Okay, so again, just writing the definition, which is basically just comes from the name. And then second part, what's the information that we know about these as well? Same thing as before. They're also going to be always supplementary as well. And I'll explain that a little bit better than I did earlier. They're always supplementary. Okay, we kind of saw this a little bit when we were working through that example on the last homework. But if I go back to this diagram here, let's just find a pair of same side exterior angles. So again, we're talking about exterior on the outside here. If I look at angle 1, the same side exterior angle to that would have to be on the other set of lines here, angle 7. So angle 1 and angle 7 would have to be same side of the transversal and then exterior. And the information that we know about them is that they are supplementary. The reason for that, kind of like we've talked about, is if I look at angle 3, for instance, well, I know angle 1 and angle 3 are supplementary because they form a linear pair. So angle 1 and angle 3 are supplementary, and then 3 and 7 are corresponding. So we know that they're the same measure. So since angle 1 and 3 are supplementary and angle 3 are the same, I can just substitute that in. So angle 1 and angle 7 are supplementary as well. Like I said, we could fill out a proof for this, but today we're just worried about the actual information itself. And then another example here of same side exterior, just in case you're curious, angle 2 and angle 8 would also be examples, okay? Good news here, if you're struggling to memorize some of the things that we work on or how to set up your problems, you always have one of two choices whenever we're doing problems with these kinds of diagrams. Either the two angles you're looking at are congruent or the two angles that you're looking at are supplementary. The way to remember this is same side starts with an S, so does supplementary. So if you see same side interior or same side exterior, that is supplementary. Anything else, whether it has alternate in it or whether it's corresponding, are always going to be congruent. Okay, just a way that you can remember that. If you remember nothing else from today's lesson, I want you to remember that. Okay, so example 2 here, we're looking at this. In this case, I'm not going to have you sketch this diagram because we understand what these diagrams look like, and now we're just kind of practicing this a little bit. Okay, so we have the measure of angle 3, which is 4x plus 16. So I'll label that on my diagram here. You can kind of just watch this piece at least. And the measure of angle 4 is 5x plus 2. And it's asking two different things. It's asking what type of angles do we have. And then in this case, it's asking what is the measure of angle 4. So first thing I need to do here is I need to figure out how I'll set up this equation. As a reminder, if I'm trying to identify these types of angles, 3 and 4, notice they're on the same side and they're on the interior. So simply enough, same side interior angles is what I want to write here. Same side interior angles. Okay, so that's the first piece, making sure I'm naming them. In most problems, you won't have to name them, but that is the piece that I'm going to be asking. So if you come up to me and ask, Mr. Brian, how do I set up this problem? First thing I'm going to ask you is what type of angles are you looking at? Okay, and now we know, since it's same side, we know that's supplementary, or in other words, we add these up to 180. So that's exactly what I'm going to do. I'm going to say 4x plus 16 plus 5x plus 2 equals 180 here. And then we know how to solve this here. We can combine like terms first. So 4x plus 5x equals 9x. 16 plus 2 equals 18. Continue to solve. We can subtract 18 from both sides. If you want to challenge yourself, you can try to do this in your head. We have 9x equals 180 minus 118. That's going to be 162. And then last step here, if I want to divide both sides by 9. Again, if you want to challenge yourself, you can try to do this in your head. If you can't do it, I'm not worried about that at all. But if you type this into a calculator, either way, 162 divided by 9 should give you 18. So x equals 18 here. Okay, and again, I'm always checking. Once I get my answer, I need to check and see, do I need to plug this back in? In this case, I do. So we have measure of angle 4. That is what we wanted to know. So I want to plug that back in here. So measure of angle 4 equals, we were told that's 5x plus 2. So 5, and then instead of x, we can plug in 18. Or substitute in 18, and then plus 2. Continue to solve here. And simplify, measure of angle 4 equals 5 times 18. Again, you can try to do this in your head, or we can use that pattern that we talked about in last chapter. It's just half the number and then add a 0. So that is 90, and then plus 2. measure of angle 4 equals 92. And I'll put degrees here. And this would be my final answer. So again, we know we're always checking to see, do I need to plug something back in? Okay, so that is example 2. And then last one here, I'll try to knock this out quickly enough. I do want you to take a second. I want you to pause your video, and I do want you to sketch this diagram here because this one's a little bit different. Okay, so we have this here, and notice we have the same kind of idea. We have parallel lines, and we have different transversals in there. We're trying to solve for a variable, but the difference in this case is our diagram doesn't look the same as it usually does. But even if the diagrams get more complex, if we still see the same ideas, then we can use this to solve these different problems here. So for example, if I'm looking at example 3 here, I see these two parallel lines, and if we're having a problem where we say we want to solve for x and y, as a reminder, let's just focus in on solving for one of them first. Could I set up an equation to solve for x? Well, notice here I have my two parallel lines, and then let's just pick our transversal, the one that deals with x here. Let's start with that. So two parallel lines, our transversal would be this, and then I could ask myself, if I just gave you this diagram and nothing else, if I just cover up this portion and just look at the top angles, notice what kind of angles do we have here. Okay, these are called same side interior angles. And whether it's same side interior or whether it's same side exterior, the good news is we know how to set this up. We know to set this up, since it's same side interior, we're going to be supplementary. So 2x plus 96 equals 180. Okay, and then I would solve from here. So I can subtract 96 from both sides. When I do that, these cancel, leaving me with 2x equals 180 minus 96. Again, you can try to do this in your head if you'd like. That is going to be 84. And then last step here, divide by 2. And I get x equals 84 divided by 2. That's just going to be 42. And that would be my final answer for x. And the good news is I don't have to plug that back in. If I wanted to double check and make sure I got it right, I could plug that back in just to see if those angles are supplementary, which they should be. All right, and the next piece here, if I'm trying to solve for y, same kind of idea. The diagram might be a little bit more complex, but if I just look for my two parallel lines and my transversal, in this case, the transversal, I want the one that's touching y, notice we have the same kind of pattern here. We have two angles that are on the same side of the transversal, and then they're both on the inside of the parallel line. So these are also same side interior angles, and that means I know that they are supplementary. So I can use that to add them up and solve here. And you can put the expression with the variable first, or you can put it second, doesn't really matter. I usually put it first just to keep the numbers close together. So instead of saying 94 plus 3y plus 44, I'm going to put the 3y plus 44 first, and then plus 94 equals 180 here. Again, they're supplementary, so I add them up to 180. And now we can solve. So first thing we want to do is combine like terms. So 3y stays the same, and then 44 plus 94, well 40 plus 90 is 130, and then add 4 plus 4 is 8, so 138 equals 180. Continue to solve here, we subtract 138 here from both sides. When I do that, these cancel, leaving me with 3y, and then equals here. Again, you could just try to do this in your head or in a calculator, but answer is going to be 42. And then last step is we want to divide by 3. So we divide by 3 here, and we get y equals 42 divided by 3, which, again, you can just type that into a calculator. That is 16. Okay? I lied. Just checking to make sure you're paying attention. That is 14. That's better. Okay, y equals 14 here. Okay? So, like I said, all you're doing on these kinds of problems is you're just trying to identify what kind of angles I'm looking at using those names. And then number 2, how do I set up my equation? Are they congruent or are they supplementary? And then just rock it out from there, okay? If you guys have any questions, as always, feel free to let me know in class. But otherwise, working on homework 3.2 for this afternoon, all right? Thanks, guys.